last time we put together a way for our player to attack or give damage. So this time we will add a way for the player to receive damage. So let's get cracking on that. To get started with, we're going to add in a damage state. And unlike most of these other states, which we enter into from these various state selection choices here, the damage state will be entered into directly from the step event because we want to be able to take damage from any state. So if we're in the move state, we want to be able to take damage. If we're jumping, we want to be able to take damage. If we're ducking, we want to be able to take damage. If we're ducking, slashing, we want to be able to take damage, etc., 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 right? So all these, so in order to be able to achieve that, since we could put a damage state check in every single one of these states, or just because we're basically checking it in every single state, we can just put it over here in the step event before we actually execute our state in the first place, and that would be a damage check in there. You can also then throw in exceptions like, oh, if I'm in an invincibility state, do not go into the damage state at that point, or something like that. It's your choice. You come up with your own ideas for how you're going to do it. This is how I did it for Zelda, for Link in the Zelda 2 game. So to get us started with, let's come over here to Event 6, and we're going to need to title it Damage State. And this is basically what we're going to do whenever we take damage. So we're going to bring in our acceleration here, just to start us off with. When you're damaged, you lose all horizontal control because you're knocked back. But you still have vertical control because you don't have vertical control. You still have to have gravity applied, though. So we apply the current Y speed, and that varies according to gravity as normal from the jump state. But you maintain the same X velocity the entire time. So you get knocked back at 1 pixel per frame, and we don't bother with adjusting the acceleration here because of that. Let's put a note in for that. X speed is constant and not adjusted. Then we bring in our speed fractions and stuff like normal. Then changing there. And we bring in our animation section. Idle or not idle. So image speed is equal to 0 because we want to, I guess I can probably delete that. That's probably an extraneous note. Image speed is equal to 0 because we aren't animating. We don't really have to actually put that, well, yes, we do, because we don't enter the damage state from the normal, we don't use the normal change state function, which automatically handles all that for us. So we need to make sure that we set the image speed to 0, index equal to 0, and image X scale damage facing direction. We'll build that in a little bit, which determines basically, when we take damage, we determine what direction the source of the damage came from, and then make sure that we are locked facing that source of damage while we are taking the knockback, so that it makes the animation look right. And if you remember correctly, our damage state we have right here, sprite link hurt. So that'll handle our sprite for the state. And I'm thinking about it, 2, 3, zoom in. Make sure you all can see the code. Now let's bring in the most complex part of this entire setup here, the state selection. It's, well, when I say most complex, it's not really all that complex. Just once the flashing timer is equal to -1, so once the flashing timer is done, then if global.current save data.current HP is less than or equal to 0, spawn the death cutscene and destroy me. otherwise, just return back to the normal move state. So nothing too complex. Flashing timer we're going to implement in our step event over here in a second. So now let's come over here to our damage check. Pull open the code over here. Let's see, it's Control M to close all the all the regions. And damage check. Damage check is really complicated. So that's why I've been waiting on this. So if I frame underscore timer underscore is equal to -1. So if we're already in the damage state, basically, if we're not in the damage state, then we can start checking to see if we can take damage. The iframe timer basically, so there are two ways to determine the damage state in Zelda here. So you have the iframe timer, which is how long you're invincible. And then you have the flashing timer, which is how long you're flashing. You're invincible for a short period of time. Come over here to our animations. We set up this earlier. Iframe timer length. You're invulnerable for 2 seconds, but you only flash for 0.75 seconds. So the reason for this is because the flashing is when your character swaps through different color palettes, so Link has different colors during this flashing period. But the iframe timer for 2 seconds, that's how long he does the blinking in and out of being able to be invisible. So the iframe timer is longer than the flashing timer. That's just how they had it all set up. So I mean, it looks nice once you got it all set up, but it's kind of complicated to think about. Let's see, simple place meeting damage check. Yeah, let's get started with that. So to start us off with, we say var underscore instance place, parent enemy, and var underscore instance projectile is parent enemy projectile. Let's create a parent enemy projectile before we forget about it and crash our game. There we go. So that should be good. So basically what we're doing here, we're checking wherever Link is at any given time for, is there an enemy there or is there a projectile there? If one or the other is true, then we'll use those in a little bit. But as opposed to, like, say, some modern games where it's like you want to check for all enemies that might be hitting you at the time. In that case, you might use an instance place list if you want to be able to take damage from multiple sources at the same time. Or maybe you want to be able to check for all the enemies hitting you and take damage from the most or least damaging source at that time. That's another valid option for a way you can do this. In this case, we don't care. We're just checking for what the first enemy that the game can find in that position is. So it's basically random. So if you have 5 enemies there, it'll randomly choose one of those enemies to be the one that is the one that damages you, because we're not using ordered list or anything. So next thing up, we do if underscore inst it does not equal no one. So I check for enemy. And if for instance for projectile does not equal no one, then that. So enemy check and projectile check. And now we're getting into the complicated code here. It's not so much complicated as it is very verbose, because you have a lot of things that you need to do when you take damage. So if there is an enemy in your place, take damage. And I'm going to bring all this stuff in because it's going to be annoying to type it all out. So here it is. global that current save data dot current HP is equal to the max of 0 or global dot current save data current HP minus max, etc., etc. So what is this little line doing here? This is basically saying, okay, let's we have an enemy, we're in the place, we're going to take some damage from it. So let's say we want to set our HP to the max of 0 or whatever our HP will be after we take damage from that enemy. You'll see this in a lot of cheap games where your health can go under 0 when you die, and it's a stupid simple thing to not do that. You just max of 0, or whatever your health will be. That's all you have to do, and that prevents you from having that little error, and it will no longer bug people who actually pay attention. So we say the maximum of 0 or your health after you take damage. So how are you taking damage? It's your current health minus the max of 1. So we're saying at least 1. You'll always take at least 1 damage. Or the instance's damage value minus your current health level, because your health level is your defense. So if you have a defense of 7 currently, and the enemy will do 3 damage, then it makes it so that the enemy only does at least 1 damage, but it won't go any further. It won't go any lower than 1 damage. So it won't give you. It won't increase your health basically. If it would be, let's see, that'd be 3 minus 7, -4, and then you have 4 minus -4. That would give you 8, right? So you don't want to be increasing the player's health. All right, so that does all that, but let's see, global current save David health level, yeah, that's in there, but we don't have instance score damage because parent enemy doesn't have a damage variable. So just for the time being, I'm going to throw in this. We'll do 0. And that'll make sure that we don't crash if we try to test run the game. Iframes is equal to true. And I don't know if this is actually even necessary. It might be just an anachronistic thing that I've set up. Because basically having iframe timer equal anything other than -1 is the same as iframes equal to true, right? So well, the main reason why I did that is because, you might want to be able to give your player invulnerability without actually turning on the flashing effect. So if you're like in the middle of a cutscene or something and you don't want to be able to take damage, then you turn iframes to true without actually adjusting the iframe timer. That makes sense, right? That's why it's there. Well, so I could probably basically at the same time turn this to I could set this up so that if I implement iframes, then it would also turn iframes true. That's just me coming up with different things I can do in the future. Flashing timer is equal to flashing length. Iframe timer is equal to iframe length. Those lengths we set up over here in our animation section. Length and length, as we remember. State is equal to player states.damaged. So that'll get us back over to this when we start executing our code. Step x fraction is equal to 0, y fraction is equal to 0. So I'm canceling out all of your current speed movements, and I'm setting your current speed movements to what I feel like, which is basically your knockback speed. So fall speed times 0.5 and applied speed, yeah. Setting the y speed to that. And var dir is equal to sine of x minus instance.x. So I'm finding where's my x position and where's the enemy's x position. And basically saying, okay, well, set my direction facing based on that. And this is actually slightly wrong. I should use sine 2 here because sine 2 is basically, if it is 0, it will always be 1. So that way, if the enemy and you are in the exact same place, then the value of sine would be 0 underneath the normal sine function, right? If you have a sign of 0 is 0, but sign 2 you sets it so that sign of 0 is 1. That's basically what it is. So it prevents you from being able to have a 0 in that instance. Excuse me. Current X speed is equal to the floor of your walking speed times underscore direction. So basically, whatever your walk speed is times underscore dir. Why did I use floor? I don't know. Walk speed is 1.5. So I basically, okay, yeah. So that's basically me saying 1. I could have just said 1, but, you know, I don't know. Maybe you have some sort of effect going on, which causes your player to move at 50% faster. So you're moving at 2.25 frames per second. So you want to have them knock back at 2 pixels per frame instead of 1 pixel per frame. Or maybe you just want to have them knock back at whatever your current walk speed is, whatever. It doesn't matter. Just come up with your own system there for your own games. Damage facing direction is equal to underscore dir, equal to dir right, then it's 1, otherwise it's -1. So basically that same code that we're always seeing all over the place for determining what direction, we're doing it again here. So that should allow us to take damage from an object. And let's see real quick here. If we go a parent enemy, and current parent enemy doesn't really do anything, so let's give you a sprite just for this. We'll eliminate it in a second here. Come into here, drag in parent enemy, put it right there so it's visible. Let's give it a test. See how well it works. Let's go into the game. Oh, there we go. Take damage. Looks like we face away from the... As you can see, we can walk through it while our iframe is currently active. And that's allowed. That's something I'd spend a lot of time having Link jump against enemies to figure out how long he can make the iframe timer and everything work properly. It looks like our HP isn't really going down or something, because it looks like we have well, oh wait, that's right. Our HP is probably going down. It's just going down really slowly, because you're only doing 1 damage here, and you have like 64 HP or something like that. So, all right. You look away when you take damage from that side. You look at it, you take damage from that side. So it looks like my math is off there somewhere. Facing damage. Let's see, instant enemy check. Let's see. The damage facing direction is equal to underscore dir. Dir is signed to, so if x oh wait. That'd be why, because no, my math isn't off. It's just the X position of the this is right there, and when Link takes damage, he's basically probably touching this, and so he gets a 1 instead of -1 because of how the math works out for him. At least I think so. I mean, if I were to change it so that your X is somewhere in the middle, then I'd find out, but I'm not going to do that for the time being. Oops, don't want to edit image or anything. What did I just do? Oh, I just added a new sprite to you. None. That's what I wanted. And delete that sprite that I just created on accident. There we go. Delete. Delete, delete, delete. All right, so what are we at? We're currently at 19 minutes. I think that's a good time to cut off here. We have everything set up. We don't have projectiles yet, but, you know, as I've been saying, you win well, as I've been showing, each time I add something new, it requires something else going on with me setting up fake variables and stuff so it doesn't crash the game. So we're just going to ignore the projectiles for the moment, and we'll just work on this. And next time we'll actually add some enemies that will start doing things that will allow us to basically take advantage of the damage functions. Right? Sounds good. All right, so thank you everybody for joining me, and I'll let Passme take it away with some Patreon names. I'd like to thank my Legacy Patreon sponsors: James Burton, JD Lowe, Suli, and Vezia. I'd also like to thank my current Patreon sponsors: Kenneth Klein, Vladimir, and Jamal. Thanks to your support, the NESGameMaker is much cooler, and I'd like to wish you all good luck with your programming.